Hello React Native developers, welcome to Can It Be Done in React Native. In this episode, we look at a seemingly simple user experience that hides a lot of details. Guys, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this week's episode, we're looking at the Reflectly color selection. When you create an account with Reflectly, you have this nice slider menu in order to select which color you want the app to use. And you can tap on a color and you have this nice background transition. And what I like about this user experience is that it's very simple. A slider, you select values, you have a transition. But then they really gave a lot of thoughts to every detail of this seemingly simple user experience. So first of all, you see that these colors, they follow some sort of a sinusoidal pattern, which kind of looks cool and feels good. And when you tap on one color, you have a nice blur effect on the radius of the circle. So it gives a nice smooth blending effect. And also the colors are a gradient, right? You can see it's actually a linear gradient. And you can move the positions with your finger, but also tap to move the slider. So you have, again, that's a common pattern we see also in our React Native apps, where you want to drive a particular UI part continuously with a gesture, but also imperatively. So for instance, here, like tapping on a button. So how would we do this in React Native? Well, we have a pan gesture handler with slides around the colors. So simple view, simple component for each color. And then we have so that the pan gesture handler gives us the X translation. We know how to do this. We use an offset. When we release the gesture, we spring to one position, the closest one. Again, we know how to do this. We have a utility function in Redash to help us calculate where to snap. And then we can calculate a Y translation that looks like a sinusoid. And for this, we can simply interpolate. So we'll see actually that by using a linear interpolation, we'll have the similar pattern. And actually that might be what is done in the app. But just to be fancy, we can follow trigonometric functions to calculate the Y translation of each color, which will give us this nice effect. And then every time we press on a button, we trigger a side effect that will trigger the background transition. So we have a circle that grows bigger and bigger, and it needs to cover all the screen. How do we, that's a use case we faced already in previous videos. How do we calculate the radius of the circle that covers? So if my phone, which is a rectangular shape, we take its max side, so here would be the height, we know that the circle that covers the whole rectangle is square root of 2 times the height. And this is the formula we're going to use. We need to take into account that we're not necessarily, the circle doesn't start at the center of the screen, but either on the left or the right side. We're going to use the tap gesture handler to know the position of the finger when we tap on a color, so we know where to start the animation. And finally, so we're going to use a single color and just animate a view. And then there is this nice blur effect and nice gradient. And one way we can achieve such an effect, which is going to be a level 2 implementation of this API is to use an OpenGL shader. So using GL React, we have the blur filter given to us for free. So what is really good about GL React for such 2D shaders is that you can build, so the circle that animates is an extremely simple shader to build. We've built in previous videos shaders which were actually a little bit more complex than this. We've always built very simple shader. And then because GL React offers us composition through React components, we can easily apply a blur filter to our shader. And that will give us the animation that you see here. And again, we can also implement the linear gradient, which is simple mix of colors depending on the position of the pixel in the shader. So overall, a very simple shader. The complex part of the shader is actually the blur effect, which is given to us for free in GL React. So that's how we would do the nice gradient blur effect. And I really like the composition model of GL React for such 2D shaders. What do you guys think? Can it be done in React Native? Let's have a look. Guys, before we get started, one thing, if you are interested to learn the fundamentals of gestures and animations in React Native, I hope that you will check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user experiences in React Native that will run at 60 FPS, even on low-end devices. So if you're interested to learn the fundamentals, I hope that you will check it out at startreactnative.dev. So here we have our boilerplate project, which you can download from the video description in case you want to follow along with this example. This time, the UI is simple enough that the boilerplate is completely empty. I just have the list of colors and I have a start and end color because it's a gradient. And so we are going to do this in 2 steps. First, we're going to do a gesture and animation without caring about the gradient, without caring about the blur. And then we're going to build an OpenGL shader and animate that shader in order to implement the linear gradient and the blur. So let's start with simply displaying these colors as a slider. So we're going to create a container here, and I'm going to create a style sheet as well. And we're going to, so let me create the style sheet before, up, container. So we do a flex one and we want to do a flex direction row. So they display horizontally. So flex direction row. And probably we want to do an align items center. Okay, and here we can loop over, so let me import style sheet, and here we can loop over the colors. So for each color, so we have the color, the index, we want to return a color component which we're going to create. We pass color as property. Key is index, and we're going to need for the animation also to get the index. Okay, so let's create quickly the color component. So color from color. Oops. Create a new file, color.txt. So we get a color which has a start and an end. So we're going to use linear gradient to display it. So start, and there is an index which we're going to use to interpolate the animation values. So it's a number. So here we have color. And so we can display our color. So it's going to be a linear gradient. So from, where can I, yeah, expo linear gradient, perfect. And so the colors are color.start, color.end. And then we need to do the styling. So we need to display 3 colors per view. So we're gonna take the width of the screen. And so from the dimension API, and then we would do color width equals width divided by 3. So we have one in the center and one in the middle of each half of the width of the screen. I'm gonna export this value. So what I can do here, I mean, let me style, okay, and we need a radius. So radius equals, I don't know, 45, for instance, let's see. And so here we can style the, so style gradient. So I'm going to create a style sheet. Styles. So we want the border radius to be of radius. Width and height is twice the radius. So width equals radius times 2. Height equals radius times 2. And we want to have like a border width. So there's a white border around. So I don't know, maybe 6 points. And border color is white. So need to import style sheet. Let's see how it looks like. Looks good. So now let's do the layout. We want to see 3 colors per screen. So we're gonna add a container. So we have styles.container. And yeah, so width is color width. And then we can do align item center. Yeah, so we have our 3 colors, that's perfect. So now let's add the gesture and animate the slider. So if we go back here, I think we're simply going to wrap this into a pan gesture handler. Single child of a pan gesture handler needs to be an animated view. So this becomes animated.view. And we're going to add the pan gesture handler. So here it is. So we need a on gesture event. And on gesture event is use animated gesture handler with reanimated view. So now we need the translate X animation value. So you can do translate X is use shared value. Let me import these from reanimated view. Couple of imports missing. And let's do a simple test on active. We get translation X. So we can simply assign translate X.value to translation X, and we can pass it here as parameter to do the translation. So we'll have translate X equals translate X in color. So let me add it to the props quickly. So translate X is an animated shared value of a number. So let me import reanimated, perfect. So here we get translate X, index, And here we can create an animated style. So animated view. We can concatenate an animated style to container. So the style is done in Reanimated 2 using use animated style. And we're simply going to return transform with translate x equals translate x dot value. Let me import use animated style. Oops, that's funny. I'm trying to move. So here it translates nicely. But of course, you see, if I release the gesture, you always starts to 0. So, I mean, this is our bread and butter. You've seen it countless times. We need to create an offset value, which I can declare here in the type system. So the first argument here is pan gesture event. So the type of gesture handler we have, here it's a pan gesture. Later we're going to use the tap gesture handler. And then our context, here we want a x offset value, which I'm declaring here. So on start, we remember where we were. So the context in Reanimated 2 in these gesture handlers just is an object that you can use to maintain a state across the gesture event. And here, the state is a current translation. So context.x equals translate x.value. And on active, we simply do, so we have x plus translation x. So now it should remember of the offset. So you see, I can move it around nicely. So that's good. And now what we want to do is when we release the gesture, it needs to snap to one particular position. So let's calculate the snap points based on the colors. So the snap, once we have the snap points, redash gives us the function to calculate where to snap automatically. So we're going to map over the colors. And so the index is minus I times width. So if we're at 0, 0, if we're at the second color, it's minus, no, it's minus color width. That's why, right? Which is width divided by 3. Oops. So these are our snap points, and let's try it. So on end, and we're going to use the velocity x of the gesture, the destination. So there is a snap point function from redash. We give it the value, which is translate x, the velocity, which is velocity x, or snap points. And we can spring to that value. So we can do translate x dot value with spring to destination. Let's see if that works. So you see now it snaps nicely to a proper position. Now you see that the first one cannot go to the middle, and this we can easily fix. Because when we're at the leftmost position, this one should be here. So we can easily fix by doing a placeholder. So styles dot placeholder, and placeholder is width is equals color width. Perfect. So you see now it snaps nicely to all positions correctly. So pretty cool. Now if we tap, we need to know the position of the finger, and then we can do the background animation. So we're going to build one simple background animation where we animate a view as a circle, and then we're going to build our OpenGL shader to use the blur and linear gradient. So I'm going to show you two implementations. So let's create a state here, which is called color selection. So when we press the button, we're going to change that state. So color selection and set color selection. And default value, so it looks like this. We have previous and current. The color in the background and the color that appears in the foreground. So here default values, I'm going to do color 0 and current color 0. And let me, so here on, we are going to create an onPress property. And we want to know where to start. So we can also maybe add position here. X0, Y0. So this is the information we want when we start the animation. So on press, we're going to get the position. And we're going to change the state. And we need to also move the value to the center. So translate X. So, okay, a couple of things we need to do here. So we need to do translate X.value equals minus index times color width. So that will snap the color to the center. Let's try that first. So here we can do a tap gesture handler. Again, here we need a animated view as a single child, but that's okay. So we want here to use a tap gesture handler so we know the position of the finger from the screen when we tap, so we can start the animation. So animated.view. And we can create our tap gesture handler. So on gesture event. So use animated gesture handler. And so this time it's a tap gesture handler event. So tap gesture handler gesture event. I think that's what we want here. And on active, so when we press, we get the XY position. So here we want the XY position based on the screen. So we're going to use absolute X and absolute Y. And we're going to pass it on press as parameters. Like this. On press. So let me add it to the props type. So we have position, X, Y. And let's see. It's not working. Let me reload. Oh, yes, of course. So here you see I write the value directly. So this is why you see this. We need to transition to it. So I can do with Spring. So now it animates nicely. Let's make the sinusoidal pattern, and also there is a scale animation to do. So the V's on the sides should be smaller. So we have our index, and we're going to use it to calculate the to interpolate the animation value. By the way, here I'm using Empress directly. I'm running Alpha 6 with Expo 39. If you are using a newer version of Reanimated, you need to use run on GS to invoke JavaScript function from the JavaScript thread from the UI thread. So don't forget to do this change if you are running a different version of Reanimated 2 than me. So we're gonna need an input range. So we know that the value in the middle is minus color width times index. And since these are negative, the one before is going to be minus color width times index plus 1. And because we subtract, and color width index minus 1. So this is our input range. And for the sinusoid, I'm going to show you two ways. So let's do, here we need to add translate X, translate Y. So translate Y. And we're going to do an interpolate. So we're going to do it linearly and it's going to look like a sinusoid. So we interpolate on translate X.value, input range, and output range. We're going to do 100.0, so middle when we're at the current position, and minus, let's say, 100 points. So you see here, no, that's not, I need to extrapolate clamp. So you see it looks like, it does feel like a sinusoid, because then it flattens here. And that's probably how it's implemented in the Reflectly app. But what if you truly want it to, I mean, I want to use trigonometry, even though it's not gonna make much of a difference. So here, instead of interpolating points, we can interpolate an angle and then use cosinus or sinus, depending on the shape we want. And we see here that if the angle, so at 0, so if we take the cosinus, which is the x coordinate on the trigonometric circle, we know that at if we want 0 on translate y, we would need to have cosinus of pi divided by 2, right? So here we're at 0. Then at if we want 1, here it needs to be 0, so cos 0 is 1, and then if we want minus 1, cos of pi is gonna be minus 1. So here, let's do an angle instead. And we said here it needs to be pi divided by 2, minus y is gonna be pi, and here it's gonna be 0. And so we have an angle. So translate y equals 100 times angle. No, cos of angle. So here, same effect, but it's truly a sinusoid. And now we can also interpolate the scale. So the scale, so that's funny, this one is cool. So we want the scale to be at 1 in the middle. So here, 1 sinus of pi divided by 2 is 1, right? We're on top. And then it's 0 on minus 1 and plus 1. It's perfect. And then we want to go, let's say, from 0.8 to 1. So we can do 0.8 plus the remaining times. So at the minimum, we want 0.8. And then we want to go from 0.8 to 1. So we do the remaining times sinus of the angle. And we can apply it here. So you see here it's smaller and it gets bigger. So it kind of looks cool. Yeah, here we're being fancy by truly using trigonometric interpolation. But of course, as you've seen, we don't need to. It works as well with a nice linear interpolation. Okay, so now when we press, let's update, and we have the position. Let's update the state. So we can do set current selection, I guess. Set color selection. We get the position. The current color is the one we selected. So color, and previous was the previously selected color. So previous is color selection.current. And now we can create a component to do the background animation, which we're gonna do here. Background, and we pass color selection as a property. So let's create this component. Let me type the color selection quickly. So we have position, X, Y, and then we have current, which is start, end, previous. Okay. And here, so we're gonna have an absolutely, right, it's in the background, absolutely positioned fill view, which is gonna be the background of the background. So style sheet absolute fill object, and then background color is color selection dot previous dot let's start. So now, right now we're gonna only look at the start color. Let me import this one here. Okay. So it's always -1, but makes sense because it's the background. Sorry, but okay. And now we can inside put the foreground. We know it's gonna be animated. And yeah, let's just create this animated style. So let's create a default style for now. So use animated style. And we can return, so let's say border radius 45. So it means width needs to be 90, height 90. The background color is the foreground color, so it's going to be color selection dot current dot start. And let me. So here it's at the top corner, so we want to have position, so remove, let me factorize this one into, so radius border radius times 2. So we top, we want first the center to be in the center of the top left corner, so we need to do minus radius, and left minus radius. Perfect. So here we have it at the corner, so we can translate it back to whatever is the position of the finger. So we can do plus color selection dot position dot for left dot x, and here color selection dot position dot y. So you see now it fits the position of the finger. Isn't that cool? So now we need to animate the scale. So we need a progress animation value. So when color selection changes, we run an animation that goes from 0 to 1. So let me create the animation value. So we're going to call it progress. Close this one here. So use shared value. And we're going to run a use effect on the color with color selection as a dependency. So color selection. And so we reset start value is 0, and then we run. So we can do, let's say, progress dot value equals with timing of 1. So here it's complaining about the dependencies, but here we know what we're doing. We can ignore it. Let me import use effect. And seems to be complaining. Let's see. So now we can scale the circle. So transform scale. So we can do progress dot value times max scale, which is gonna be, so at 1 we have this value. So the max radius we need to apply is so we know that it's a math square because we've done it before and we've calculated the formula manually before. It's square root of 2 times the height, but here we can even do the max of with height, and I probably need to import width and height. Yes. So from the dimension API. So this works if we always start at the center. So this is max radius. So the max scale is max radius divided by radius. But this works because I'm probably wrong in my formula. Because if it was I was just calculating, so if I do 8, so I'm doing something wrong, because if I was only scaling enough, since I'm not scaling from the center of the screen, you should see the circle not covering completely the screen. So there's something is off. So is it height divided by 2? So let me do this one again, divided by 2. Oh. Let me reload. Something's off. Maybe also here I can make it slower, add some easing. So 7, let's say 650. Easing in, out. Now we have it a bit. You see here, we do see the corner. But, and so what I want to do here is to simply add position.x and position.y from color selection. Here it's a bit, I think the math here is wrong, but it does give the desired effect. And so now, does it? Right? Perfect. So now what we can do is to replace this component with an OpenGL shader. So we did, so it's complaining about, where did I typed? Sorry, one second. Here it should be strings. This is why also, so I had some type errors. So we can replace this component now with an OpenGL shader. So we're going to create a new background component and we're going to call it background.gl. So let's create this component. The props are the same, right? So let's just get the color selection. And we're going to need to create a surface from GL React. And we're going to have our node, which contains the shader. So surface and node we get from GL React. So actually here for the boilerplate, we wrote such shaders in previous videos. And I do have the Philips Hue here example where we wrote such a shader. So we're not gonna need all these things. So we don't need the size, we don't need these functions. So let me just, so we have the main. So a shader is a program which is compiled and executed on the GPU. Here we receive the pixel info coordinates and we calculate its colors also based on parameters which we can give, which I removed. For instance, here we pass the size parameter. So yeah, let me clean this one up. So here we have, so to draw the circle, we're going to calculate the distance of the pixel from the position of our finger. So this one is going to be position. Right, and if the distance is less than the radius, we display the foreground color. If not, we display the background color. So let me see. So here, node parameter, we have shed. I'm just looking at the. So this is how it looks like on the U example. Right? Yeah. So here we can do style sheet absolute fill. Which we need to import. we need to import also this one. Perfect. Oops. And so we need uniforms. Here also I have color selection as prop. So color selection, position, current, and previous. Okay. So here we have shaders. Okay, let's call it background. Shaders.background. No, sorry. Here is the shader. So here in uniforms, these are the variables we want to pass to our shaders. So for instance, the position. So it's a vector of size 2, so we use an array. So we can do position.x, position.y. Then we need to pass the colors. And here I have, okay. So I have a utility file. So I'm gonna call it GL utils. Let me get it from Gist. So it's a utility file that has two functions. One to convert a string color into a vector of three components which we can pass as a uniform. And then there is a use GL progress hook that allows us to animate GL shaders without triggering a React re-render. So here we use set draw props, which enables us to update the OpenGL shader without triggering a render on the React side, a bit like set native props. So let's pass some colors. So we can do, let's say, background color start would be. So we need our function to convert colors, which is called colors to vector. Perfect. And so would be previous dot start. And then we can do the same for the foreground. So I'm missing a comma here. So let's declare these in our shader. So position is a vector 2. So we use the uniform keyword here. So uniform, the color is a vector 3. So background color start, and same for the foreground. So and so here, if the distance is smaller than radius, so that's the interesting part. Now here, our shader is a rectangle. So the canvas goes from I think -1 to 1, or no, it goes from 0 to 1. But because the width and the height are not the same, it's gonna look distorted. And so the way I want to not have to worry about it, and I want the circle to not be distorted, to look like a circle, I'm gonna make this a square. And so I'm gonna take the height and make the width the height and center it on the and so the way you do it, so let me create styles.container. So create container. So we do want the so position absolute. The height is the height. And yeah, I mean, here we know because it's in portrait mode. Let me get the height. So we need width height from dimension API. The width is going to be the height. We want it to be square, so things don't look distorted. So width is height, but now we want to center it. So top is 0, but left is the delta. So so it would be height minus width divided by 2. And we slide it to the left, so minus. And this should center. So now he's complaining about. Let me reload maybe. Is something wrong with the imports? Let me check the boilerplate. Node, shaders, and surface is the wrong. That's the wrong import. We need to do import surface from. So I'm just here looking at the Philips Hue example to copy the boilerplate. So that gives us surface. Is there a type for this? Let me check. It seems like there is. That's very impressive. Wow. Oh, yeah. Wow, incredible. So now let's look at our shaders. Radius. Let's take, I don't know, 0, 1. And so here, so let me remove. So if we are inside, we show the foreground color. So that would be foreground color start, opacity 1. If not, would be the background color. Let's try that. But I'm a bit worried. Yeah, let's see. Background. We don't see any background. I'm a bit worried. Okay. So yeah, this looks as expected, but we obviously did something wrong with the positioning of our Canva. Here I forgot some parentheses, right? So it would be, you know, not 8 minus width divided by 2, but 8 minus width divided by 2. And I can remove this outer parenthesis, I guess. That looks good, but we don't see the original circle. So if I say half here, let me see. We don't see this. Oh yes, of course, sorry. We need to convert this position into the Canva coordinate that goes from 0 to 1. And here we have something that goes from 0 to height, so we divide by height. And here it's divided by width, but we are translated to the left, so we need to add this part. And we need to divide by 8 actually. So plus and divided by 8. We don't see the, because here you might have cut it already. I'm using previous, I should use current. So now we see perfect. So let me make it a bit smaller and let's animate it. So, oh, is that correct? Let me check again. Let me see. It's not here, yes. On the y-axis it's reversed, right? I think. No, it would be 1 minus this ratio, I think. It looks good. Looks good. Perfect. So now let's animate. I have a utility function to do it. So here we're going to need the ref to redraw without re-rendering. Use ref of node. And so we can use here node directly. And okay, set, yeah, this method is not, that's fine. So let me use GL progress. So we see if it's in, yes. So let me see the parameters. I think the first one is the node and then the uniforms. So uniforms, so I'm gonna create it here. And we're going to create a progress value in the shader. And so we can do progress equals 0. And in this hook, we animate a progress value. And what trigger the progress value is the dependencies. And here the dependency is going to be color selection. Okay, like I can do current. Okay. I think just any here. Okay. So now let's so instead of being 0, 1, let's try progress. Yeah. Now it animates nicely, and these are fun. And then we can do now the gradient. So we're gonna pass the color and also as uniform. So color and write a simple linear gradient function. So that would be current and foreground. And so now, okay, so now here we're going to run, so let's create a gradient function. So that returns, let's say, a vector 4. So we would have gradient start, which is a vector 3, and end, which is a vector 3. And so we're going to return a vector 4. And so we're going to mix every values, right? Every components. Based on UV. On UVY. And so we go from here would be start.x, end.x, right? So depending on the Y position, we either, if we're at 0, we want to use start.x. So here, the X is the R component of the color, the Y is the RGB, the green component, and so on. And I just lost I think my mouse is running out of battery. No, still 25% should be good. So same here for the Y component. And here's the Z component. And so here we can run gradient, foreground color start, foreground color end, and we can do it the same for the background. So it didn't compile the shader. Let's see. So background, so the shader is not compiling. Yes, of course, here I'm using TypeScript syntax. It's not how you do type annotations in C++ or in shaders. That's right, the Java syntax. And so now you do see the gradient, right? You see it, huh? You see it's different color. And I'm just wondering if we can actually do it just a mix directly on. So if I do, can I do this? Start, end, and uv.y. Let's see. Yeah, looks good. Isn't that cool? Oh, and I forgot the most important part, the blur. But this we have for free because there is a GL blur component, which is a package. So let me go to the GL blur. So for instance, there's this one here, which we can use. And I'm gonna import blur from GL React Blur. So here you see the nice blur effect that we got for free. It looks very cool. So here we really reproduced nicely the user experience. Guys, I hope you enjoyed this example, a seemingly simple user experience that made us use a lot of different recipes from our gestures and animation tool belts, trigonometry, tap gesture, pan gesture, so having one user interaction that is driven continuously from a gesture or discretely, imperatively, and these things which were somewhat hard to do in Reanimated 1 are quite easy to do with Reanimated 2. And we deployed an OpenGL shader. When these are simple enough, they are always a lot of fun. We do have to cross the bridge to animate each frame, but here, because it's a one-off tap gesture, it's probably okay. And it's not the last we're gonna see of OpenGL shaders in this series. So I am really looking forward to talk to you soon, and until next time, happy hacking.